Hello, my name is Carson French, OMS2, here on the Cherokee Nation campus, and today I will be presenting our research on the association between COVID-19 related anosmia and the structural development of the primary olfactory cortex and hippocampus among pediatric individuals. The COVID-19 pandemic has profoundly impacted child development, and one notable symptom, anosmia, a loss of smell, is often reported in those infected with the SARS-CoV-2 virus. While anosmia is well documented in adults with prior COVID-19 infections, there's very little information available on the impact of neural structures in pediatric individuals who experience COVID-related anosmia. This is particularly interesting to us because the neuroplasticity of the brain is at its highest up until adulthood, which would lead us to question the long-term potential effects of COVID-19 on a child's development. Our study aims to evaluate whether a prior COVID-19 infection, particularly those who experience anosmia, is associated with any structural changes in key brain regions involved in the olfactory system. To do this, we utilized MRI data from the Adolescent Brain and Cognitive Development, or the ABCD study. The ABCD study is a large-scale, longitudinal, open data neural imaging study that utilizes fMRI and SMRI to analyze neural imaging quantitatively. The ABCD study consists of over 12,000 children born between 2006 to 2008, so initially about ages 9 to 11 years old, that were assessed in person at one of 21 testing sites across the United States for a baseline visit and then follow-up visits after. To do our study, we performed a cross-sectional analysis to compare MRI scans taken before the COVID-19 pandemic with scans taken during the pandemic. This allowed us to evaluate structural changes over time. We used a regression analysis to compare differences in brain volume growth between children with and without COVID-19 and further analyze the difference between those who experience anosmia. Our sample, after exclusion criteria, consisted of about 9,611 children, 694 of whom reported a prior COVID-19 infection. Among the participants with COVID-19, we found a significant difference in the hippocampal volume in those who experienced COVID-19 related anosmia compared to those who did not. However, there was no significant difference found in other olfactory related brain structures. Implications of our study. So for our results serve as a possible piece of evidence that prior COVID-19 infections in pediatric populations have the potential to cause long-lasting effects on neural development. We are particularly interested by the fact that the hippocampus was affected due to the hippocampus's major role in memory and learning. Anosmia has been linked as a potential indicator for certain pathologies, though there isn't any certain or any current work on COVID-19 related anosmia and the risk of developing other pathological conditions. Further work could evaluate for these potential increases in risk of developing certain conditions like neuropsychiatric and neurodegenerative conditions later on in life. Overall, with more studies, we could understand these risks and allow for healthcare workers to monitor children with COVID-related anosmia and consider early interventions that could possibly mitigate these possible long-term impacts. In conclusion, we found a significant association between COVID-19 related anosmia and smaller hippocampal volumes in pediatric participants. This study highlights potential importance for monitoring children with anosmia for potential long-term developmental changes. Future research could explore the mechanism behind these structural changes and their impact on the cognitive and emotional outcome of children. I'd like to take the chance to thank fellow co-authors Ashley Buzzle, OMS2 also, and Dr. Micah Hartwell, PhD, for their work and help on this project. Thank you.